Yeah, hello everyone. This is Professor Abdul Razak from Anjuman College of Engineering. Uh, Today we will learn data structure and stack. Okay. In the previous few lectures, we have already gone through uh, decision statements, if else, right? Then loops, while loop, do while loop, for loop, then function calling mechanism, call by value, call by references, then types of the function, then arrays, and after that we have learned one dimensional, two dimensional array. So some portion of the array that is used in data structure that is yet to be discussed. So in today's lecture, uh, we will see what operations can be performed using array. Okay, so just just hold on. I need to check whether I am audible or not. So, hello everyone. I'm Professor Abdul Razak from Anjuman College of Engineering and Technology. So, in the previous few classes, we have already discussed. Uh, we have already discussed different types of decision control statements like if else, switch case, uh, then condition statements. After that, we have gone through different types of uh, loops like do while loop, while loop, for loop. After that, we have learned functions, then recursions, then various mechanism of calling the function like call by value, call by reference. Then we learn how to deal with similar data type. I mean, we deal with arrays. Then we have seen one dimensional array, two dimensional array. Now, today we will see what are the different data structures and what operation we can perform on those data structures, right? So, similarly on arrays, we are performing certain operations like searching, sorting. So, we will see these things in brief also. Okay. So, let me continue. I'm starting my PowerPoint presentation here. Okay. So, data structure and stack. So, in this slide, we will see what are the operations performed on array. Then we will see what is linear data structure. After that, we will see stack. Then we will learn stack, overflow, underflow, then operations on stack. Then we will see the operations, push operation. After that, we will see pop operation. And finally, we will see application of stack. So, what are the operations performed on the stack? Sorry, what are the operations performed on array? So, the various operations performed are searching for an element in the array, whether a particular element is there in the list or not. This operation is called as what? Searching. Similarly, for certain application, we may require to arrange the elements of array into some order. This may be increasing order, this may be decreasing order, right? So from application to application, the order may be the required order may either be increasing order or decreasing order. It is also called as ascending order or descending order. Then the next operation we perform on the stack is what? Traversing. Okay. Traversing means what? Visiting every element of the array. Okay. Then other very common operations are insertion, then deletion, then updation. What do we mean by insertion? Insertion means adding any element into the array. Okay. So it grows the size of the array. Similarly, deletion. Deletion means what? Deleting the element from the array. Means removing the array elements. So it reduces the size of the array. Similarly, updation. Updation means what? From existing value of the array, it is altered, it is changed to some other value. Means previous value will be lost and in place of its previous value, new value will be assigned. Okay? And it should be kept in mind that the type should always be same. Before updation, the type of the array, what was the type of the array, it should be same after the updation. Because array will never accept the mixed elements. Okay. So let's see this one by one. Searching. Searching refers to finding an item in the array. Okay. So the result of the execution of the searching algorithm is whether the element is there, is the message whether the element is there in the list or not. If it is there in the list, then we will specify its position in the array. And if it is not there in the list, okay, excuse me, there was disturbance of voice, that's why. So if it is not there in the list, then it will give us the message that the particular element which you want to search is not there in the list. Okay. So in general, we are using two searching algorithms. Okay. Those are what? Linear search and binary search. So as the name suggests, linear search means what? Searching the element in the array in the linear fashion. Linear fashion means what? First we check whether the initial element of the array is same as the element we are searching for. Then we will go for the next element, next element, next element. Okay. In this way, we starts from the zeroth element to the n minus one element. If suppose the element is nowhere, if match is successful, then we will give the message that the element is not there in the list. So this will be beneficial. Linear search will be beneficial when the size of the array is very less. Okay. But if size grows, then suppose the size of the array is say 1000, then searching 1000 element will take making 1000 comparison will be a time consuming task. So if the size of the array grows, if it is large, then we will not use linear search. Instead of that, we will be using binary search, right? So what is binary search? As binary means what? Two. So we are dividing the search area into two portion and always start searching from the mid position. Okay. So we will see these algorithms in detail in the later slides. So now what do we mean by sorting? Sorting refers to rearranging all the items in the array into increasing or decreasing order. Okay. Now sorting algorithms include selection sort, insertion sort, bubble sort, quick sort, merge sort, etc. Okay. Now let's see what is linear search. In the given figure, there is an array of size 9. Okay. So indexing starts from, just a minute. So I don't know whether the previous slides were visible to you or not. So these are the content of the slides: operation on arrays, then linear data structures, then stack overflow and underflow, then operations on stack, push operation, pop operation, and finally the application of stack. So the operations on array include searching operation. Searching operation means what? Checking in the or searching in the array whether the particular element is there in the array or not. If it is there in the array, then we will specify its position in the array. If it is not there in the array, then we will give the message that the particular element is not there in the list in the given array. Then sorting. Sorting means what? Arranging the array element into some order. This order could be increasing order or could be decreasing order. We will say that it is ascending order or it is descending order. Then the next operation we perform on the array is what? Traversing. Traversing means what? Visiting every element of the array. Means we are traveling the array elements one by one. So this process is called as what? Traversing. Then insertion. Insertion means what? Adding element into the array. So it grows the size of the array. Then deletion. Removing the existing elements from the array. So this means what? uh, Removing the elements means after this operation the size of the array get reduced. And updation, we are changing some of the array will be as it is, but we are changing some element of the array. Okay. It should be kept in mind that whatever value with which we are changing the element, it should be of same data type. Data type should never be altered, right? So after updation, the size of the array will remain same. It will not be disturbed. Only what gets changed, it's a particular some particular value that we are going to change. Then we will see searching. So searching refers to finding an element in the array. Okay, whether the element is there in the list or not. So after making several search from start to end, okay, if the element to search is not matched with any of the element in the array, then we will give the message that the particular element is not there in the list. Otherwise, if match is successful at some instant, so we will stop searching more and instantly come outside the loop and give the message that the element you want to search is at such and such position in the array. Okay. So there are two different methods or searching algorithms. Those are what? Linear search and binary search. So what do we mean by linear search? Linear search means what? Linear search means what? Searching the element. Just a minute, because every time I need to check whether it is working or not. So am I audible or not? Let me ensure it first. Then we will continue. Yeah. Continuing with the slides. So, as I told you, there there are two searching algorithms: linear search and binary search. So, linear search means what? As the name suggests, we are searching the array element one by one, okay, in the linear fashion. We are starting from the first element, then go for the second, third, fourth, and up to last element, right? And binary search means what? As the name suggests, we will binary means what? Two. So we will search the element by dividing the search area into two parts. How do we divide? Always we calculate mid and compare the element to search with the mid element. Okay. If it is matched, then the result will be given. If it is not matched, then either we will choose the first portion and discard the second portion if it is less than, and if it is the key is greater than the mid element, then we will discard the previous portion and choose the next portion. And in this way, every time we will divide the search area into two portion, and every time we are discarding one of the portion and continue with the other portion, right? Now sorting refers to rearranging all the items in the array into increasing or decreasing order. Okay. Then sorting algorithms are selection sort, insertion sort, bubble sort, quick sort, and merge sort. Okay. So in this small time span, we cannot complete all these algorithms. So uh, we will see few of them. Now let's see the detail of linear search. Okay. Here the list is given to us. The array, it is an integer array having 9 elements. Their indexes are from 0 to 8. Okay. Now suppose using linear search algorithm, we are searching whether 20 is there in the list or not. So first we will compare 20 with the zeroth element of the array, that is 10. If it is not matched, the index is incremented by 1. Then 20 will be compared with 50. If it is not matched, okay, then we increment the index, then 20 with 30, not matched. Increment the index, 20 with 70, not matched. 20 with 80, not matched. 20 with 60, not matched. Then 20 with 20. Here it is matched. So at the same instant, when the match is successful, we skip uh, for comparing the rest of the element, because our ultimate aim is to find whether the element is there in the list or not. Since we have found the element, so we will come outside the loop and give the message that this particular element 20 is at location number 7, not 6. In terms of array, it is 6th position, but in normal counting, it is at the 7th position. So we will give the position as it is present at I plus 1. Why I plus 1? Because indexing in array starts from 0 and actual position is always 1 more than the index of the element. In this way, we can give the message. Now, this is the linear search algorithm. Okay, so it is there are the variables I, position, key, temp. Okay, and 20. And 20 is what? It is the size of the array. Flag will indicate whether the match is successful or not. Initially, flag is 0 means match is not successful. As soon as the match is successful, we make the flag as 1. So flag 0 means what? If flag remains 0, then match is never successful. If flag becomes 1, so element has been matched with the array elements. Okay. Okay. So here this question printf uh, first to be list to be search, printf list to be search. So here we are displaying all the elements of the array. These are the 20 elements of the array. We are displaying these 20 elements. Then asking the user that which element you want to search in this list. So he will enter some value that is stored in the variable key. Okay. Now we are establishing a loop from 0 to less than n, means from first element to last element we are searching. First element is having the index 0 and last element is having the index n minus 1. So that's why we have taken the condition as I is less than n, and every time we are incrementing the variable I by 1. Okay. And in this loop there is only one statement. What is that? If list of I is equal to key, means the particular index of list whether the element present is equal to key or not. If it is present, then our job is over. So we make the flag as 1 and position as I, because when the element is found in the list, then we need to give its position also. We will not directly give the message that element is there in the list. Along with this message, we have to give the position at which position the element is there. So that's why we are taking the position variable. Now here we are checking if flag is equal to 1, means this statement has been executed. If this statement has this if block is executed, it means this condition would have been 2 at some instant. If it is 2, this means what? This means the element is there in the list. Okay. And if flag is not 1, means else part. So key not found, element is not found in the element. So what we have taken here in the if part, element percent d is found at location number percent d. So percent d at first percent d key value means what element we are searching for, that will be printed. At the second percent d, what gets printed? Position plus 1. So to give the actual position in the list, right? So in this way, the linear search algorithm works. Okay. So in the same algorithm, let's say we are searching whether 12 is there in the list or not. So in the first iteration, I is what? 0, and list of I is containing list of I means 0th uh, at 0th position of list. What is there? 14. Okay. So this is what? 14. So we are checking I is less than equals to 19. It should be equal to again also, right? So it is true because 0 is less than 19. So list of I is equals to key? No. So every time it is no. So let me go to the previous slide. So we are searching 12. So 0, 1, 2, 3, 4. At the means when the value of I is 4, what will happen? So when I will be 4, list of I will be 12, and I is less than, uh, it should be 20. Uh, here, by mistake, I have written 90, it should be 20, because we are using the symbol I is less than. So list of I will be 12 and key will be 12. So here the match is successful. So flag will be 1. In all previous cases, the flag will be 0. Okay. So if flag is 1, means element is there in the list. Let's take one more example in which the element is not there in the list. So what will happen when the element is not there in the list? Let me put it here. Okay. So at the 0 value of I, match is not successful. Means at all the instances, because 7 is not there in the list. You can see 7 is throughout the list. No, 7 is not found anywhere. Okay. So in all these cases, match is not successful. So list of I is never equals to key. So flag will remain. It was earlier 0 and it will remain 0 throughout the program. Okay. Now I will increase up to 19. It is okay. Now every time I is incremented by 1. So I will become 20. But 20 is less than 20 will be false. So we'll come outside the loop. After coming outside the loop, the flag was as it was 0 and this statement is never executed. So it will remain 0. So if part will be false, so we'll go to the else part and it says that the key is not there in the list. So in this way we will find this. Now the other method of searching is what? Binary search. Okay. So what is binary search? Dividing the search area or complete array into two parts. So here uh, an array has been given to us. The size of the array is what? 10. Okay. So indexing starts from 0 and last element will be having the index as 9. And we are searching here element 23. So we will not search 23, we will not compare 23 with 2, then 5, then 8, unlike linear search. What we will do? We will calculate the mid position. So 0 is the initial index and 9 is the final index. So 0 plus 9, it will be 9. 9 divided by 2, so it will be 4.5. But integer by integer will always give us as integer. So 9 divided by 2 will give us the 4, value 4. So we will compare 23 with 60. Okay. But we find here that 23 is greater than 16. So obviously this portion is not important for me. Yes, one important thing I forget to tell you that for binary search, it is must that the list should be sorted. Okay. Knowingly or unknowingly, we are applying binary search in the real practice, where when we are searching a particular word in the dictionary, so we are not comparing that word which we are searching for with each and every word of the dictionary in the sequential manner. What we are doing, we are opening a dictionary at random position and check whether the first letter appear on that page is same as the first letter of the word we are searching for. If it is not so, so either we will choose the left part or we choose the right part and discard the other part. Okay. So the same thing we are applying here. And why we are searching dictionary like this? Because the words in the dictionary is arranged in the alphabetical order. If it is not arranged in the alphabetical order, then we cannot perform searching in that way. Okay. So we find here that the 16 in this example, which we were learning, we find here that 23 is greater than 16. Okay. So 23 will be, as it is greater than 16, so it will be present in this portion, in the right hand side portion. So left hand side portion should be discarded. So how to discard it? So for this portion, this should be my high. High should be as it is, but low should be what? It is 5. How we will get 5? It is mid plus 1. So whenever the key is greater than the mid value, then we will make the low as mid plus 1, and whenever the key is less than whenever sorry whenever the key is greater than the mid value, Then we will choose the next part, right hand part. For that, we will make low as mid plus 1. And whenever the key is less than the mid value, then we will choose the left part, first portion, and discard the second part, right hand side portion. So for that, we are making the high as mid minus 1. Okay. So in this case, mid was 4. Okay. So we will make low as 5, mid plus 1. Okay. Now here low is 5 and high is 9. So 5 plus 9 is 14. 14 divided by 2 is what? 7. Now we will compare 56 with the key, and we find that this 56 is greater than the key. Okay. Or the key is less than 56. So if it is less than, then we will choose left hand side portion. So to select this, low will be as it is, but high will be what? Mid minus 1. So it will become high will be 6. Okay. So again, uh, low plus high, 5 plus 6 is 11. 11 divided by 2. 11 divided by 2 is what? 5. So now the value at mid means at position 5 is 23. So match is successful. Okay. So in this way, we can go for the binary search. So here we can check that. So here we can check that. Just a minute. Just a minute. I'm disturbing with the calls. So I'm okay. So here in the binary search we are checking that we are seeing that in the three attempts we find 23. But if we would have chosen the linear search, then this unsuccessful, unsuccessful, unsuccessful. So we require I think 7 attempts. So in the 3 attempts only we find the element in the list. So that is the advantage of binary search, right? So if the size of the array is less, then we will choose linear search. Otherwise, we will choose if it is large, then we will choose binary search. So this is the algorithm of this is the program for binary search. Okay. Here we are taking one array num of size 10. Okay, it is having elements 0 to 9. So what is the least index? That is low is equal to high, low is equal to 0. What is the highest index? That is 9. So therefore high is equal to 9. Key is the value or number which we want to search in the array. Okay. And mid, as I told you, that every time we start searching from the mid position, and flag is an indicator. If it is equal to 0, it means the yet the element has not been found in the list. If it becomes 1, it means what? Element has been found. Okay. So clear the screen. Then enter key numbers between 0 to 9. Means here we are asking for the number which user want to search in the given list. Okay. We can also make the provision of deciding the list by the user also. But here, for the cause of simplicity, we have initiated the array with the numbers which we want, right? So in the do while loop, the condition has been given. by what time we will continue this searching. So till the time low is less than equals to high, we will continue this. If low is greater than high, then we will stop and give the message that the particular element that we are searching for is not there in the list. Okay. Similarly, either we can use the break statement in the loop, or we can, if we are not using, then along with the condition we can write if flag is equal to 0. Till the time flag is 0, we will continue this. If flag becomes 1, because our ultimate aim is what? To find whether the element is there in the list or not. If it is there, then no need to continue the searching. If it has been discovered that the element is there in the list, so we will not completely search the list. As soon as the element is found in the list, we will skip the rest of the portion of the array, right? So that's why we are taking flag. So in the loop, do while loop, here you can see, first, we are calculating mid as low plus high divided by 2. If key is equals to num mid, means mid element is same as key, then we find the element, and so we give the position mid plus 1. The element has been found at the position mid plus 1, and flag is equals to 1. Okay. Otherwise, if it is not found, mid element is not same as the key, then either we discard the first portion or we discard the second portion. So to decide it, we need to check that if key is less than num of mid, or if it is greater than num of mid. Okay. So there are three cases. Key is equals to num of mid, means our ultimate aim has been achieved. Key is less than num of mid, and if its else part means what? Key is neither equals to nor less than, so obviously it is greater than. So for greater than, if the key is less than num of mid, then we will use the first portion. For that, high is equals to mid minus 1. If this is not like this, then else part means what? Key is greater than num of mid, then we will go for the next portion, second part. So for that, we will make the low as mid plus 1. Once you go, means if you dry run this program, then you will learn the existence of each and every instruction in the program. Why a particular instruction is there, has been taken in the program. How do we realize? If we dry run the program. Okay. And at last, we are checking if flag is 0. When flag will be 0? When this match is never successful. So flag was 0 and it will remain 0. So if it remains 0, it means what? No match is successful. If no match is successful, it means what? Element is not there in the list. So we will give the message that element is not found. This is the example of dry run. We are trying to find 11 in the list. So k is what? 11. So in the first iteration, my low will be 0 and high will be 9. So 0 plus 9 will become 4. So low is less than equals to high. Mid is equals to, oh sorry, let me check. Just a minute. Low is 0 and high is 9. Okay, high is 9. So 0 plus 9 will be what? Just a minute. Just a minute. 0 plus 9 will be 4. 0 plus 9 will be 9. 9 divided by 2 is what? 4, not 5. So here again, 5 has been taken with by mistake. It should be 4. So we will check 4 is equals to, at the fourth location, element 4 is there. So 4 is not equals to 11. So we need to go for the next portion. So for that, we have taken low is equals to mid plus 1. So mid will become, low will become 5. So 5 plus 9 will be 14. 14 divided by 2 is 7. So here it automatically gets corrected. Okay. So now we will check the element at 7th position. So it is not matched. Okay. So we will, uh, what should I say? We will make high as mid minus 1. Okay. So it will become 6. Now low is less than high. This condition becomes false. So it will come outside the loop. So no mid will be calculated and flag is still 0. So if it is still 0, it means what? Element is not there in the list. The second try run is for finding the element 5 in the list or not. So we are seeing here that element 5 is there in the list at the location number 5. Okay. So here my key should be what? 5, not 6. Okay. If we are searching 5, then k should be 5. If we are searching 6, then k should be 6. Okay. So if k is 5, so in this case also low is 0 and high is 9. So 0 plus 9 is what? 4. Okay. So the element is not matched. I show you in the program itself because the value I have considered is wrong. So first low is this 0 and high is what? 9. 0 plus 9 will be 9. 9 divided by 2 is 4. So at fourth position we are not we are searching 5. So 4 is not matched with 5. So we will choose this part. So for that my low should be mid plus 1. So low will be 5 and high will be 9. So 5 plus 9 is 14. 14 divided by 2 is 7. So mid will be 7. Again 7 is not equals to 5 because we are searching 5. So we will choose this portion. So my high will be mid minus 1. So high will be 6. So 5 plus 6 is 11. 11 divided by 2 is what? 5. So mid is 5. So finally 5 is matched with 5. So we will give the result that the element is there in the at the sixth position. Okay. Now let's see the selection sorting algorithm. We will see only two sorting algorithms: selection sort and bubble sort. Okay, there are other algorithms also, but that will be taught to you in another session by another experts, right? So in selection sort, what we are doing, we are fixing the first element and comparing it with the next element. So 4 is compared with 9. We are, if no order is mentioned, we should always assume to be in ascending order. Okay. If order is mentioned as descending, then only we consider it to be descending. So 4 is less than 9. It is in the order. No need to swap. Then 4 with 5. Okay. In the second line, you can see 4 with 5, it is also in the order, no need to change. Then 4 with 1, it is not in the order. So 1 will take the position of 4 and 4 will take the position of 1. So this is called as what? Swapping. So here 1 occurs, 1 with 0. It is again not in the order. So we need to swap it. So 0 will be here and 1 will be here. So after one iteration of selection, this is one iteration from start to bottom. This is one iteration. After one iteration, completion, you find that the lowest element 0 has got its actual position. Now 0 is sorted. Now our list, unsorted list should be reduced. So in the unsorted list, the elements remains are 9. Let me show with the arrow: 9, 5, 4, and 1. Okay. Now 9 will be compared with 5. It is not in order, so 5 will take the this and so in the same way as we have as we did for the first iteration, in the same way we go for the next iteration. So total iteration required is always one less than the size of that. Okay. Sometimes it is the fortunate part that we got the sorted list in some um, before the last iteration, right? So this is the example of selection sort. Okay, in a 100 elements are there. N is the size. I j are the indexes, position, then swap. So here I have divided the program into parts. Okay, the complete program is not there. Okay, enter the elements. In advance, we have taken size as 100. But if you want to work for the 10 elements only, so we will apply the loop till 10 only. Rest of the elements will be having the garbage value, and it will never be referred or manipulated, or any calculation will not be performed on the value beyond 10, right? So we will take the size of the array in advance. If we are giving this facility to decide the size of the array to the user, then take a sufficient size in advance. Okay. So we have taken 100. Now suppose users choose size to be 20. So n will be 20. So this loop will be continued for 20 times, and 21 to 100 this will be garbage, and this will never be referred in the program, right? So here we are entering the element in the array. Then here onwards we are applying the selection sort algorithm. I is equal to 0, I is less than n minus 1. Why n minus 1? Because the last element is having the index as n minus 1. Okay. So every time we are fixing in the first iteration, we are having the I value as 0. For this loop, inner loop, I will always be fixed as 0. Okay. So as we have seen in this iteration, that every time first element means what? Element having 0 index is compared with the second element, third element, fourth element, and so on. So this is fixed. So that's why every time the position is fixed as I. Okay. After one iteration, I will be incremented by one because the one element is sorted. Then remaining array is to be sorted, and this portion is to swap the elements. Okay. How to swap the element? How we exchange two values? By using one intermediate variable, that is swap. And this is what displaying the sorted element. Now bubble sort. In bubble sort, what is happening? This unlike selection sort, this was fixed. So in bubble sort, this is not fixed. One is compared with six. If it is not in the order, if it is in the order, let it be as it is. Now six will be compared with the next element. Now, now after exchange, the third element with fourth. After exchange or not exchange, fifth element with six. Now sixth element with seven. So in this way, if we continue, then after the first pass or first iteration, we find that the last element, the highest element got its position. So this list here onwards, this side, right side, this is sorted, and left side it is unsorted, right? So in the second iteration, 1 with 5 order, 5 with 6 order, 6 with 4 not order. So we will interchange this 4 with 6. Now 6 with 8 again order. So this will be as it is. Okay. We can skip here comparing 8 with 9 because 9 has already got its position. Okay. If we are comparing this, then unnecessarily we are increasing the complexity, right? So in the bubble sort algorithm, the program is same, only the logic of rearranging the element is different. Okay. So every time the elements compared are the adjacent elements. So first element is a of j, then the element to compare it with is what? A of j plus 1. Okay. And this is again to exchange the values, right? If you make a table of I, j, num, right, and temp, and go through the program, means if you are making the dry run of the program, then you will get the reason of every instruction present in the program. Okay, even we cannot change any sign, and this is the portion which displays the result after the sorting has been performed. Right now, our main objective of today's lecture is what? Learning the data structure stack. So data structure can be divided broadly into two types: primitive data structures and non-primitive data structures. What do you mean by primitive data structure? These are our that integer, float, character, double. These are the primitive data structure. And non-primitive data structure, on these subject is there in the computer science data structure. So non-primitive data structures are the logical way of arranging the data. Okay. So at the time of making the storage of the data into the memory, there should be some consideration that what is the way of updating its value, what is the way of inserting the value into it, what is the way of removing the element from it, and to make all these operations easy, we are arranging the data in several different ways, right? So these are called as what? Data structures, or specifically non-primitive data structures. Okay, so non-primitive data structures are again divided into two types: linear data structure and non-linear data structure. So what is linear data structure? Linear data structures are the data structures in which logically the elements are arranged in the linear way. Linear way means what? Uh, there is should not be any hierarchical relationship between the elements. And in non-linear, from one node there can be many nodes, many child nodes. Okay. Then linear can again be static or dynamic. In the static, we are having array. In the dynamic, we are having linked list, stack, and queues. Dynamic means what? Static means what? Once the size has been fixed, it will always be the same size. And dynamic means what? Depending upon the requirement, and as the programming continues, its size may change, its size may vary. Vary means what? If you are inserting the element, then it should accept that insertion, and after that insertion its size will grow. If you are deleting the element, then it should accept deleting, and after the delete operation, its size should get reduced. Okay, so this is in this sense we are saying this array as the dynamic. Okay, now non-linear data structures are again divided into tree and graph. Okay, so these portions will be covered in the other lectures by other experts. So linear versus non-linear data structure, a type of data structure that arranges the data items in an orderly manner where the elements are attached adjacently. This is called as linear. A type of data structure that arranges data in sorted order, creating a relationship among the data elements. In linear data structure, memory utilization is inefficient, whereas in non-linear, memory utilization is efficient. Here the level is single, here the level is multi-level. It is easy to implement and it is difficult to implement. Examples of linear data structures are what? Arrays, linked lists, stack and queues, and non-linear are what? Trees and graph. Okay. Here are some more differences was in the definition. In linear data structure, we traverse through element nodes sequentially. In non-linear data structure, one node may be connected to several different nodes, so can't be traversed sequentially. In this, no sequence is there, but in the linear, there should be some sequence. Okay. Now we will come to the main topic of today's discussion. That is what? Stack. Okay. So stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO or FILO. LIFO means what? If we make some restriction of insertion and deletion, okay, we are making only one end of operation. Okay, one end is closed and another end is open. So, and from that end only we are inserting the element and we are deleting the element. I think my screen, okay, it is shared. So, if from that end only we are inserting the element and we are deleting the element, that end is called as what? Top of the stack. So, in short, it is called as top of stack. Okay. So obviously, if we put this restriction, then the last element inserted will be the first element taken out. So this is also called as what? Data structure of type LIFO, last in, first out. Or it is also called as FILO, first in. The element which is entered first will be the element taken outside at last. Okay. An example of the stack is what? If in a plate container we are putting the plates, then the first plate entered in the container will be the last plate taken out, and last plate put in the container will be the first taken out. Okay, so plate stacked over one another in the canteen. The plate which is at the top is the first one to be removed. That is, the plate which has been placed at the bottommost position remains in the stack for the longest period of time. So it can be simply seen to follow LIFO, last in, first out, or FILO, first in, last out order. Right? So here in different colors, the object plate has been shown. Okay. So first we inserted this. Okay. First we inserted this, then yellow, then purple, then blue. Okay. So this is the order of insertion. So what is the order of deletion or removing? What is the order of removing? First we remove this blue, then right, then this purple, then yellow, then pink, then light blue, and then this is milky. Say okay. So in linear data structure, where insertion of the element or deletion of the element, insertion means what? Adding. Deletion means what? Removing. So insertion of the element or deletion of the element is done from only one side or one end, which is called as top of the stack. Right? Now, what are the operations performed on the stack? So there are only two operations performed on the stack. One is inserting elements into the array or adding element into the array. It is called as push operation. And another is deleting elements from the array, means removing elements from the array. It is called as pop operation. Okay. So push and pop, these are the only two operations which are performed on stack. Okay. So in this figure, the name of the data structure is what? Stack. So only through this end only we operate. Through this end we can't do anything. Okay. So push. So here this end only we will push. Push means what? Adding the element into the array. Okay. Pop means what? Removing the element from there. So either we want to add the element or into the array, or we want to take the element outside the array. It should be the same end. Okay. And that end is called as what? Top of the stack. Fine. So in here is some example. So top is what? Initially minus 1. Minus 1 means what? Stack is empty. Okay. Why it is not 0? because if the index of the array is 0, so it is the index of the first element, means once one element is there in the list. Okay, since the indexing of the array element starts from 0, that's why top 0 means what, one element is there. So that is why top is equal to 0 is not the condition for the empty stack. Okay, so what is less than 0 is what, minus 1. So top is equal to minus 1. Top is equal to minus 1. This is the condition that our stack is empty. Okay, when the element is inserted into the array, okay, then our top is incremented by 1, and when the element is deleted from the array, removed from the array, then top should be decreased by 1. Okay, so here top was minus 1. We push one element 6. So 6 will be pushed and top will be incremented by 1. So top is equal to 0. Top is the variable which is always pointing to the topmost element in the array. So here no topmost element, so it is minus 1. Here topmost element is 6. The index of 6 is 0. So that is why top is equal to 0. Now again we are pushing 4. So one more element is added. Okay. So top was earlier 0. After incrementation top will become 1. And through figure also you can check, this is 0th index, this is first index. So what is the index of the uppermost element? That is 1. Again we are pushing 2. Okay. So 2 will be pushed. So top will be what? Again increment. After pushing it will increment by 1, again push, increment by 1, again push, it is incremented by 1. Okay. Now suppose I write pop. Okay. See, with the push we should write the elements to enter. Okay. For pop operation, the we need not give the element to delete, because deletion always starts from the top end, right? But insertion will also be performed from the top end. But what element you want to enter, that need to be specified, right? So simply I have written here pop. Pop means what? Delete the topmost element. So 2 will be deleted. So earlier top was 2. So top is decremented by 1. So top will become 1. And 2 is not no more the part of the array now, or part of the stack now. Again we push 10. So 10 will take this position. Okay. So again top is incremented by 1. Top will be 2. So in this way, the insertion and deletion or push or pop operations are performed. Okay. Just two things we have to remember. If we are inserting the element into the array, then top value will be incremented by 1. If we are deleting the element from the array, then top value will be decremented by 1. Right? So see, one more figure is here. Let me shift this to some other position. So the stack is having four elements A, B, C, and D. Okay. So where my top is pointing to the topmost element, so it is pointing to B. Now this indicates we want to add one more element E into the list. So after this, now my top should point to this location. So obviously earlier it was to D, so incremented by 1, now it will point to E. Suppose we write pop, so E will be incremented, E will be there, but the top will be decremented by 1. So top will point to the element D, right? So the same thing which I was telling you, here the element E is added. Now we are, this indicates that we are eliminating E. So after eliminating E, as E is not the part of the stack, So my top is decremented by 1 to point to element A, right? Now let's see the two conditions associated with the stack. Before performing push and pop operation, we should first check for its validity, whether the push is valid. Okay. Suppose my array size is 10 and 10 element has already been entered. So can I enter the 11th element? No. Okay. So if 10 size of the array is 10, so what is the value of top? All the elements have been all the 10 elements have been entered in the array. So what is the value of top? It will be 9 because indexing starts from 0. So last element will be 9. So if it is pointing to the last element, okay, it means the position has all the position has already been occupied. So this is the condition of stack overflow. Okay, pushing element when the stack is already full. Okay, this is called as what? Stack overflow. When top exceeds the size of the stack, means all the position has already been occupied and you want to add one more element. So it is not possible because all the position has already been occupied. Okay, so this situation is called as what? Stack overflow. Similarly, stack underflow. Underflow means what? There is no element in the array. There is no element in the stack. Stack is empty, and you want to eliminate the element. You want to remove the element. If element is not there in the list, how can we remove the element? Okay. So this situation is called as what? Stack underflow. Okay. So performing pop operation when the stack is empty is stack underflow, and performing push operation when the stack is already full, then it is called as what? Stack overflow. Okay. When top equals to 0, then it is stack underflow. But it is in the general sense top equals to 0. Okay. In the pseudocode, the counting starts from 1, but in terms of C or array, the counting starts from 0. So it should be not 0 when top equals to -1. In terms of C programming, if we are speaking about, then top is -1, then it is what? Stack underflow. Top is equal to 0 means what? One element is there in the list at the location at the index 0, right? So condition for stack overflow, stack underflow. This is the situation when the stack contains no element. At this point, the top of the stack is present at the bottom of the stack. And stack overflow is what? This is the situation when the stack becomes full and no more element can be pushed on the stack. At this point, the stack top is present at the highest location of the stack, right? So condition for stack overflow is what? Top of the stack is what? N minus 1, where n is the size of the stack, because the last index is always 1 less than the size of the stack or size of the array. And condition for stack underflow is what? Top of the stack is -1, because somewhere you find top of the stack is equal to 0. That is also correct, but considering it in general, not in terms of C. Okay, if we are considering it in terms of C, indexing starts from 0. So top of the stack is -1 is the condition for stack underflow. Okay, these are the pseudocode for algorithm of push. Okay, and when we want to push some element, then some value should be given. Which value we want to push? Push operation will be obviously performed, but which value you want to push? So along with push, you should give some value. If top is equal to max, okay, again I am telling you this is pseudocode. So here counting starts from 1 to n. Okay, if it is array, then counting 0 to n minus 1. Okay, so if top is already max, then output an error that the stack is full. If it is not so, then add 1 to the top and at the put data in value into top position end if and end procedure. इसका हम प्रोग्राम भी देखेंगे इसके बाद में. Then algorithm for pop. If top is equal to 0, then stack is empty or underflow. Else Output value from stack at top position, subtract 1 from top. Whenever element is deleted, then top of the stack will be decremented by 1. Whenever element is added, then top of the stack is incremented by 1. This is the program for push. So max is 50, top is equal to minus 1, and here the array is of size 50 max. Okay. Now, whenever we want to push an element, the element should be given. Now, first we are checking if top is equals to max minus 1. If top is equals to the last index, max minus 1 means what? Last index. Means all the position has been occupied. So we print the message stack overflow and return. If it is not so, means top is equals to max minus 1. If it is not so, then it should be less than. Okay. So what we will do, we will increment the top. So next value of top will be taken, and at that index the item will be assigned into the array, and we give the message push element is percentage. Pushed element is percentage at that item. Similarly, for pop, okay, if top is equal to minus 1, it means what? The stack is empty. If it is empty, how can we eliminate the element from this? Okay, so we cannot perform this operation. So stack is empty and we will exit. Otherwise, if it is not minus 1, then we will give the element at the top position and simply decrement the top as top minus 1. And these are the applications of stack. Okay, startup and shutdown, then function calling, then recursion in C, then argument passing in C. Okay, I hope the each and everything of stack is clear to you. So this is all about from my side for the Prerna scheme gate lectures. Rest of the topic data structures will be taught by some other experts. So thank you very much. So we will end the session here. If you have any difficulty, you can post your queries on my WhatsApp number, or even you can call me. Okay. So thank you very much.